It would detonate and destroy all of New York City, parts of Connecticut, and New Jersey. This is maybe one of the best-kept secrets in our material science. Betelgeuse, an eminent marvel gracing the night sky, is a well-known, very large red supergiant star. It is located in the Orion constellation, astounding stargazers for quite some time. Recent statements from renowned physicist Michio Kaku have raised concerns, suggesting that Betelgeuse might have finally detonated. How this event reshapes our understanding of stellar life cycles and the forces shaping our universe is a crucial question. What insights does it hold for us? Stay tuned to find out. Imagine looking at the night sky and seeing a stunning star in the Orion constellation. Betelgeuse, also called Alpha Orionis, is a massive celestial body, located at approximately 5 hours 30 minutes right ascension and 0 declination. It gets its name from the Arabic word Ibt al-Jawza, meaning the giant shoulder. In 1603, astronomer Johann Bayer gave the star its notable name, Alpha Orionis, signifying its prominence as one of the most conspicuous stars in the Orion constellation. Despite being considered the brightest in Orion, Betelgeuse proudly holds its name as a supergiant. It has a mass several times greater than our Sun, making it a true giant compared to our solar system. To put it into perspective, if the Sun were a small marble, Betelgeuse would be a colossal ball. Determining its exact distance has been challenging, with estimates placing it somewhere between 500 and 600 light-years away, a vast distance in cosmic terms. In terms of brightness, Betelgeuse shines brilliantly with an apparent magnitude of around 6. Harvard professor Morgan McLeod noted that Betelgeuse's size and proximity make it one of the few stars that astronomers can closely study using telescopes on Earth and in space. Telescope images reveal Betelgeuse's unique features, showing a surface distinctly different from our Sun's smooth appearance. Instead of a uniform sphere of extremely hot plasma, Betelgeuse appears as a collection of uneven, bubbling gas pockets, some nearly as large as smaller stars. Massive ejections of hot material rise from Betelgeuse's outer layers, resembling cosmic spring cleaning. One such ejection was so enormous that traveling at the speed of light, it would take 75 years to cross it. This phenomenon, known as a surface mass ejection, releases material from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. However, these releases are not constant, but fluctuate in response to Betelgeuse's internal cycles. At just 10 million years old, Betelgeuse is astonishingly young compared to our Sun. Despite its youth, it has already burned through much of its hydrogen fuel, entering the later stages of its life. It is now in the red supergiant phase, where it fuses helium to produce carbon through nuclear fusion processes, driving rapid and extreme changes due to its immense initial mass. Scientists suggest that Betelgeuse began its life as a blue-white star, belonging to the largest class of hydrogen-burning main-sequence stars. The size of a star directly correlates with its brightness and energy output. Larger stars like Betelgeuse shine more intensely and burn fuel more rapidly. However, this also leads to faster hydrogen depletion and an earlier transition into the red supergiant phase. Betelgeuse's surface reaches scorching temperatures of up to 8,950 degrees Fahrenheit, a sharp contrast to our Sun's cooler 10,000 degrees Fahrenheit. As Betelgeuse exhausted its hydrogen and began fusing helium, its outer layers expanded dramatically, making it one of the largest stars known, with a diameter exceeding 700 million miles. Currently, its surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun but vastly more luminous, shining 7,500 to 12,000 times brighter. In 1836, astronomer John Herschel noted fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with intermittent changes in brightness, generally following a multi-year cycle. In 2019, Betelgeuse exhibited an unusual deviation from its typical behavior. Betelgeuse's recent activity has drawn attention due to unexpected fluctuations. Its brightness, which usually follows a steady 400-day pattern, peaked at magnitude 1.3 before dropping dramatically to around 2.8. These fluctuations were linked to the photosphere, the outermost layer of the star that emits most of its light and heat. Convective movements within the photosphere, where heat travels from the interior to the surface via gas currents, cause variations in brightness over time. During late 2019, Betelgeuse experienced a dramatic dimming of about 60%, marking a significant departure from its usual pattern. The cause was a massive ejection of material, which formed a colossal dust cloud that obscured our direct view of the star. Although the dust cloud eventually dissipated, Betelgeuse has not fully returned to its previous state. Moreover, its multi-year brightness cycle has shortened to just 200 days. Betelgeuse's unpredictable behavior has sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star exhausts its remaining fuel, its core collapses, leading to the formation of a black hole while its outer layers are expelled at speeds of up to 25,000 kilometers per second. If Betelgeuse were to undergo a supernova, it would be a spectacular event, visible for months, similar in brightness to a full moon. Given its proximity of just 650 light-years, it would be one of the brightest supernovae ever observed. While star explosions are common, they are usually too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a major event for astronomers. As stars age, their cores accumulate iron, eventually triggering a supernova. The most recent supernova visible to the naked eye, SN 1987A, occurred in 1987 at a distance of approximately 168,000 light-years. Though visible without telescopes and providing critical insights into stellar evolution, its vast distance from Earth meant it had no significant impact on our planet. Betelgeuse, a star at the center of scientific attention, is expected to go supernova. Astronomer Miguel Montoro, an expert on Betelgeuse, predicts that when the supernova occurs, its brightness will rival that of the full moon. Imagine a remarkable 2-month period when, on a clear night, you could read a book illuminated by Betelgeuse's explosion. In 2021, Betelgeuse experienced another dimming event similar to the 2019 anomaly, with a 60% decrease in brightness due to a dust cloud within the star's stellar wind. This cloud obscured part of the star, making its southern hemisphere disappear in telescope images. Following this dimming event, Betelgeuse unexpectedly brightened again, though the cause remains unclear, sparking further speculation among astronomers. Now 15 to 20 times the mass of the Sun, Betelgeuse falls into the category of stars expected to go supernova. Astronomers generally estimate that Betelgeuse could explode within the next 100,000 years. However, a recent study by Hideyuki Seo and colleagues from Tohoku University suggests that the star may be closer to detonation than previously thought. There are differing opinions on this conclusion. Seo's team bases their hypothesis on Betelgeuse's behavior, consistently expanding and contracting with periodic irregularities. While they do not predict an imminent explosion, they suggest it could occur within the next 1,000 years, challenging previous time. It's fascinating to think about what will happen when Betelgeuse finally goes supernova. The explosion will release an immense amount of energy, briefly making it one of the brightest objects in the night sky. Given its relatively close distance, the supernova will be visible even during the day, rivaling the brightness of the full moon for weeks. Astronomers anticipate that when Betelgeuse explodes, it will produce a Type II supernova. This type of explosion occurs when a massive star exhausts its nuclear fuel, causing its core to collapse under gravity while the outer layers are violently ejected into space. This process results in the formation of either a neutron star or a black hole, depending on the star's final mass. One of the most intriguing aspects of Betelgeuse's eventual supernova is the impact it could have on our understanding of stellar deaths. Observing a supernova at such close range would allow scientists to gather unprecedented data, shedding light on the processes leading up to and following a star's collapse. Instruments like the James Webb Space Telescope, along with ground-based observatories, will be able to study the explosion in real time, analyzing the emitted light, neutrinos, and cosmic rays. Will Betelgeuse's supernova affect Earth? Despite its potential brightness, Betelgeuse's explosion poses no direct threat to Earth. At roughly 650 light-years away, it is far enough that the radiation and particles released won't cause any harm to our planet. However, the event will be a spectacular astronomical phenomenon, providing scientists with a rare opportunity to study a supernova within our cosmic neighborhood. Supernovae are crucial to the universe's evolution. When a star explodes, it releases heavy elements like iron, nickel, and oxygen into space. These elements become the building blocks for new stars, planets, and even life itself. The remnants of Betelgeuse's explosion will eventually spread across the Milky Way, contributing to the formation of future celestial bodies. When will Betelgeuse explode? The big question remains. When will Betelgeuse actually explode? While some researchers suggest it could happen within the next few thousand years, others believe it might not occur for another 100,000 years. The star's irregular behavior, its pulsations, dimming events, and mass ejections, suggests it is in the late stages of its life, but pinpointing an exact timeline is challenging. For now, astronomers continue to monitor Betelgeuse closely, looking for signs of impending collapse. When it finally goes supernova, it will mark one of the most significant astronomical events of our time, an event that humanity will witness in real time, providing valuable insights into the life cycle of massive stars. Until then, we wait and watch as Betelgeuse continues its celestial dance, knowing that one day it will light up the sky in a way we've never seen before. Anyway, some researchers contend that stars like Betelgeuse can keep going for more than 10 million years, a surprisingly brief period for stargazers, yet broad in the enormous scope. As they look for hints about whether the brilliant star could turn into a supernova, stargazers have noted changes in its color. Some describe the star's shade as similar to Saturn's yellowish color instead of Mars' reddish hue. This brings up the question, has the star's color changed? If so, it could indicate rapid development, suggesting a supernova could happen sooner than expected. This color shift offers a clue to the star's changes, helping scientists decipher cosmic events. Whether Betelgeuse undergoes a supernova on time or takes its time to put on a magnificent show, humanity will have a front-row seat to witness the climax of one of the most extraordinary cosmic phenomena. What might happen if Betelgeuse went supernova? The possibility of a supernova appearing in our sky has captured people's imaginations. New simulations are helping astronomers understand what we could witness when Betelgeuse eventually explodes, potentially within the next 100,000 years. However, uncertainty remains. Betelgeuse is around 500 light-years away, and recent research suggests that for a supernova to have a noticeable effect on Earth, the star would need to be within approximately 150 light-years. Around 2.6 million years ago, an event of this nature may have played a role in a mass extinction affecting marine life after the Pliocene extinction. If a supernova were to occur within 30 light-years of Earth, things could get precarious. However, Betelgeuse's supernova is not expected to threaten life on Earth. There may still be some environmental impacts. The explosion would produce a surge of ultraviolet radiation, possibly causing a brief reduction in the ozone layer. However, research shows that any resulting ozone depletion would likely be minor and temporary, with limited environmental consequences. Shortly after the explosion, we would detect massless particles called neutrinos, which are harmless to us. The star would quickly become brighter, reaching a luminosity similar to the full moon. In just a few days, Betelgeuse's brightness would increase dramatically, illuminating our skies for about 6 months to a year. As it fades, it would remain a visible spectacle for another 1 to 2 years before disappearing. Eventually, Orion would lose its red glow, a light forever etched in memory. Following a supernova, the explosion would generate cosmic rays, high-energy particles that can penetrate Earth's magnetic shield. However, apart from the nearest supernovae, these amounts would be relatively minor compared to other forms of radiation we experience. The supernova's final dazzling display wouldn't just amaze us. It would also create radioactive iron, a crucial signature found in Earth's seabeds and even on the Moon. This iron, born from a supernova that occurred 2 to 3 million years ago, was about 300 light-years from us. Fortunately, its proximity posed no significant threat to life on Earth. Rest assured, such a nearby supernova is an extremely rare event, possibly occurring only once in a billion years. As speculation swirls around the potential arrival of a Betelgeuse supernova, astronomer Andy Howell from the University of California isn't satisfied with simple back-of-the-envelope calculations. Seeking precision, he enlisted the help of two former graduate students, Jared Goldberg and Evan Forrest. Their detailed simulations portray the star's epic finale, incorporating uncertainties while drawing insights from observations of the 1987 supernova, SN 1987A, the closest recorded supernova in modern history. These astronomers concluded that life on Earth would remain safe, though the cosmic event would certainly not go unnoticed. According to Goldberg and Forrest's findings, when Betelgeuse ignites, its brightness will resemble the soft glow of a half-moon, shining about 10,000 times fainter than the full moon. This mesmerizing brilliance is expected to grace our skies for over 3 months. Later studies indicate that Betelgeuse is closer to 724 light-years away, safely outside the common danger zone. However, the supernova could still have fascinating implications for Earth. Howell notes that many animals rely on the moon for navigation and may become confused by a bright new celestial object. Even astronomers would face challenges, as the intense brightness would surpass the capabilities of telescopes and space observatories. To compensate, telescopes would need to capture the subtler, softer glow of the star. Experts assure the public that we will have ample warning if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals, such as neutrinos or gravitational waves, generated by the explosion, giving us a heads-up as much as a day before the event. Although this event is unlikely to occur for another 100,000 years, Betelgeuse will eventually go supernova. The outcome will depend on the materials left behind after the grand finale. As scientists continue refining their predictions and expanding their understanding of such cosmic phenomena, observations of similar stars at different stages of their evolution provide essential data for modeling the life cycles and potential explosive ends of massive stars. This information helps astronomers evaluate the frequency and impact of supernovae in our galaxy, contributing to a broader understanding of cosmic events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in refining the cosmic distance scale. Precise measurements of such stars' luminosity and behavior improve our methods for determining distances to far-off galaxies, enhancing our overall mapping of the universe. Moreover, supernovae serve as crucial laboratories for understanding the formation and distribution of heavy elements, such as iron and nickel, throughout the cosmos. These elements are fundamental for the formation of planets and life as we know it. Meanwhile, space observatories are closely monitoring Betelgeuse and similar stars, using cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to observe and study one of the most dramatic events in the universe's life cycle, deepening our understanding of the dynamic processes that shape the cosmos.